What is up, guys? Mr. Rushka here. We're back with the 4.5 notes, okay? So you guys will be watching this video before class while I'm gone, and then working on the homework with Mr. Miller. So be sure to ask him questions. He can help you out. I think a lot of these notes were actually made by him, so he's the expert here, okay? So we're going to start with, today we're going to talk about graphing systems of linear inequalities. We'll start with this first example here. So we have two inequalities here, which we refer to as a system. A system of linear inequalities, okay? That just means there's multiple inequalities, okay? So we got y is greater than or equal to 2x minus 4, and y is less than or equal to negative x plus 1. So the way we do these, we just graph each of them individually. So we're going to graph the first inequality first. So let's maybe highlight. I'm going to highlight this top one in pink. I'll highlight the bottom one. Oh, it's a good color. Green, I'll do green. Pink and green go together all right. Okay. All right, so I'll use my pink pen. I'm going to graph this top inequality first. What I do is I graph it just as if it were the line y equals 2x minus 4. So I'm going to graph that line. So y-intercept down 4. Slope is 2. Okay. This graph paper is a lot finer. Okay. Recall from the last section that I'm using a solid line here because I have a greater than or equal to symbol, okay? And I'm going to shade for that one. I'm going to shade for this top inequality, okay? So this pink line here is the line where y equals 2x minus 4, okay? I want to shade everything where y is greater than or equal to 2x minus 4. So I'm going to shade above the line because as I go up, my y variable gets bigger as I go up. So I want y to be greater than this line. So I'm going to shade everything to the left of this line. Oh, hey. All right, here we go. All right, it's not, here we go. All right, so I'm going to shade everything to the left of that line, okay? Now let's do this bottom one, I guess in green, okay? So this is y is less than or equal to negative x plus 1. So this is just like graphing the line y equals negative x plus 1, okay? So I'm going to graph this, right, y-intercept right here, and then my slope is negative 1. Ooh, I think, are they opposite and reciprocal? No, they're not. They kind of look perpendicular, but they're not. Okay. Again, I'm using a solid line because I have a less than or equal to symbol, okay? All right, so then I got a shade, okay? So I'm going to shade, oh, whoops. And then I got a shade. I'm going to shade everything. Okay, so this is the line where y equals negative x plus 1. We want y to be less than or equal to negative x plus 1. So we want it to be less than or equal to this line. So we want it to be below. We want y to be below this line, so I'm going to shade below the line. Okay. All right. There we go. Okay. So I'm done with my shading, okay? And then my solution region, it's just like the intersections from yesterday. So just like intersections. Right, what did we do? So what does that mean when I say it's just like the intersections from yesterday? It means we keep the region where both colors are shaded, where both colors are shaded, okay? All right, so it's no color here, so we're not going to keep that. It's just pink here, so we're not going to keep that. Not going to keep that. It's just green here, so we're not going to keep that. But here, right, it's shaded in both pink and green, so this is going to be our solution region. So let me erase the shading I do have and then fill back in this part right here. So this means that any ordered pair I pick from this yellow region is going to solve this system of inequalities, okay? So that's it for A. That's it for example A, okay? Let's move on to B here. B, okay? So let me highlight this top one in pink. Oh my gosh, what's going on with my highlighter? Okay, and then highlight the bottom one in green. One thing I want to do with that bottom one first is I want to get y by itself so I can graph it just like it's a slope-intercept. So I'm going to write y is greater than negative 4 minus x. There we go. Okay. Here we go. Okay, so that's going to be, I'm going to highlight that in green. Why did it do that? It's not. All right. All right, so now, we're going to graph this pink inequality just like it were the equation y equals 2x minus 1, right? So y-intercept is negative 1, and then my slope is 2, okay? So let me graph that. All right. Again, I use a solid line to graph this because it's y is less than or equal to 2x minus 1, okay? So I graph that. Where am I going to shade? Let's see where I'm going to shade. Well, we want y is less than or equal to 2x minus 1. This pink line is the line where y equals 2x minus 1. We want y to be less than that, right? So we're going to shade below the line, below the line. All right, so we shaded there. Okay, now let's move on to my green inequality. Y is greater than negative 4 minus x. And again, we're going to graph this just like it were the line y equals negative 4 minus x. But keep in mind, since we have just a greater than, doesn't have an or equal to, it's just y greater than, we got to do a dashed green line when we graph this, okay? All right, so y-intercept is negative 4, okay, and then my slope is negative 1. There we go. There we go, okay? So let's see where we're going to shade. So this green dotted line is the line where y equals negative 4 minus x. We want y to be greater than that line, though. We want y to be greater than negative 4 minus x, okay? So we want to shade above the green, okay? Above the green line. All right, so let's do that. There we go. And then again, just like in the last problem, we keep the region where both colors are shaded, okay? So here I have no colors, so that's not my solution. That's not part of my solution. Here I have just green, so that's not part of my solution. Here I have just pink, so that's not part of my solution. I want to shade over here where I have both my pink and my green shaded. So let me get rid of the green, get rid of the pink, and then I'm going to keep this region where I had both colors. Okay, there we go. Hopefully it's not too complicated. Ask Mr. Miller for questions. Pause, rewind, play on like half speed. Whatever you want to do, okay? So that's B, part B. All right, part C, moving on to part C, okay? So I have this top inequality in pink. I have this bottom inequality in green, okay? So this pink inequality, I'm going to graph just as if it were the line y equals 2x plus 1, okay? And I'm going to use a solid line because it's y less than or equal to, okay? So I have y-intercept, and then its slope is 2, okay? So let me graph that. There we go. So I graphed the pink line. So this is the line where y equals 2x plus 1, but we want y to be less than or equal to 2x plus 1. So we're going to go down below for my y, because y's got to be less than this line, okay? So let me shade in pink below the line. There we go. All right. So now let's look at this green inequality, right? This is the same thing as graphing y equals negative 3x, and then I guess you could throw in a plus 0 because your y-intercept is going to be 0, right? But remember, since it's a y less than, just less than. There's no, like, it's not underlined here. It's just a less than symbol. We got to do a dashed green line, okay? So y-intercept is at the origin, 0, 0, and then my slope is -3. So that's what? Down, over 1, down 3. So there we go. There we go. Keep going. Keep going. Ugh, there we go. So hard. Anyway, so now we are going to shade. So this is the line where y equals -3x. This is the line where y equals -3x. We want to shade where y is less than -3x. So where y is below the line. So, okay, so we're going to shade below the line in green. Okay. There we go. Okay, and again, right, we're going to keep the region right here where both my colors are shaded. So this is my region with no color. That's not part of my solution. This is my region with only green, so that's not part of my solution. This is my region with only pink, so that's also not part of my solution. We want this region here where both my green and my pink are shaded. So let me get rid of this highlighting and then shade this region down here where I had both colors shaded. Okay, that's my solution. All right, so that's part C in the books. Okay, so rewind, pause, go see Mr. Miller, ask Mr. Miller for help if you're still confused. Okay, so yeah. All right, so over here, we got x plus 3y is greater than -6. Okay, so before I highlight that, I want to put it in slope-intercept form. So I'm going to subtract, oh gosh, I want to subtract x from both sides because I want to get y by itself. All right, so I subtracted x. Now I'm going to divide by 3. Okay, so I have y is greater than -2 minus 1/3 x. Okay. So that's my first inequality that I'm going to shade. Okay, and then I have my green inequality here. Oh, whoops. I have my green inequality here. Okay, so this pink line, this pink inequality I'm going to graph just as if it were the line y equals -2 minus 1/3 x. Okay, but what sign do I have? I have just a greater than. It's just greater than. So I'm going to use a dashed line. Okay. So y-intercept is -2. Okay, and then minus 1/3 x, so down 1, right 3. Okay. There we go. So that's a decent sketch of that line. And then this is the line where y equals -2 minus 1/3 x. I want all my y's that are greater than -2 minus 1/3 x. I want them all the y's that are greater than the points on this line. So I'm going to shade above the line in pink. No. Okay. Let's move on to my green inequality. Y. So this is y is less than -2. Y is less than -2. I'm going to graph this as if it were the line y equals -2. Okay, but again, this is just y less than -2. So I'm going to use a dashed line because it's just less than. It's not less than or equal to. Okay, so the line y equals -2 is right here, or wait, -2. Sorry, that's positive 2. The line y equals -2 is right here. All right, so there's that. So this is the line where y equals -2. I want y to be less than -2. So I'm going to shade down below that green line. All right, so I'm going to shade. All right. Good. And again, I'm going to keep the region where both my colors are shaded. So this has just pink. I'm not going to keep this. This has no color, so I'm not going to keep this region. This has just green, so I'm not going to keep this region. My solution is going to be this region here with both pink and green shaded in, okay? So let me get rid of my shading and then use my yellow. So I'm going to keep this region right here, okay? So there's my solution, okay? Part D in the books. Slow down, rewind, ask Mr. Miller for help if you need to, okay? All right, let's move on to part E. Part E, y is greater than or equal to -2, and y is greater than or equal to 6, okay? So we'll shade this top one in pink, shade the bottom one in green, okay? All right, so I'm going to graph this top inequality just as if it were the line, oh gosh, just as if it were the line x equals -2. So it's x is greater than or equal to -2. So I'm going to shade with a solid pink line. Oh, whoops. All right, so I'm going to use a solid pink line to graph x equals -2. That's that vertical line through here. Okay. And then I'm going to shade, where am I going to shade? So this is the line where x equals -2. I want to shade all the x's that are greater than or equal to -2. So x gets greater as we go to the right. So all the x's greater than this line are going to be to the right of this line. So I'm going to shade to the right of the line. Okay, so I did that. Now let's move on to my green inequality. Y is greater than or equal to 6. So I'm going to graph this just like the line y equals +6, okay? I'm going to use a solid line because I have y is greater than or equal to 6, okay? So that would be right here. There we go. All right, so y is greater than, so this is, green line is the line where y equals 6. We want to shade all the y's that are greater than or equal to 6, so bigger than the line. So we're going to shade above the line, okay? Let's use my green highlighter, okay? And we're going to shade all of this. All this, okay? And again, we're going to keep my region right here where both colors are shaded, okay? This has just pink, so we're not going to keep this. This has just green, so we're not going to keep this. And this has no color, so we're not going to keep that, okay? So let's get rid of this, and then our solution's going to be this region right here. Okay. There you go. Example E in the books. Okay, so slow down, pause, rewind, ask Mr. Miller for help. Part F. We got a triple here. 3 linear inequalities, okay? All right, so we're going to do this just like we're doing these examples up here. We just have a third inequality to graph, okay? So first I want to get everything in slope-intercept form. So I'm going to subtract x from this one to get y by itself, okay? I'm going to subtract x from this one and then divide by -1 to get y by itself. So I'm going to have y. So from this first one, I'm going to have y is greater than or equal to 1 minus x. The second one is going to give me y is greater than or equal to -1 plus x. And then right here, I'm just going to have x is less than or equal to 4 still, okay? All right, so I'm going to highlight these. Top one will be pink. Middle one will be green. And I think let me do red for, that's a little too similar to pink. Let's try blue. Let's do blue, okay? All right, so this top inequality, I'm going to graph just as if it were the line y equals 1 minus x. And again, I'm going to use a solid line because I have y is greater than or equal to 1 minus x. Okay, so graph the y-intercept of +1. Slope is -1. kind of trippy. All right, that's good enough. There we go. All right, so then I'm going to shade, this is the line where y equals 1 minus x. I want to shade all the y's that are greater than or equal to 1 minus x. So I'm going to shade all the y's that are above this. There we go. All right, let's move on to the second one. I'm going to graph my green inequality just as if it were the line y equals negative 1 plus x. Right here, I'm going to use a solid line. Okay, so my intercept is negative 1. Slope is 1. These are perpendicular. These slopes are opposite and reciprocal. All right. So this green line is the line where y equals negative 1 plus x. I want to shade all the y's that are greater than or equal to negative 1 plus x. So greater than this line. All right, so I'm going to shade above the green line. All right. So, right, with these other problems, we'd stop right here. The only difference here is we got to shade one more inequality, okay? So this, I'm going to graph this blue inequality just as if it were the line y equals 4, right? And I'm going to use a solid line here, solid line. So x equals 4, sorry. Did I say y equals 4? I'm going to graph it as if it were the line x equals 4, okay? So that's what I'm doing here. X equals, get vertical lines, okay? Right? So this is the line, this blue line is the line where x equals 4. I want to shade all the x's that are less than or equal to 4. So less than or equal to this line means to the left of it, because x decreases as we move to the left. So I'm going to shade all that in here. All right. Now what we do here is we're going to keep the region where all 3 colors are shaded in. So let's look at this, okay? So this has no color. We're not going to keep this, okay? This has just pink. We're not going to keep this. This has just blue. We're not going to keep this. This has green and pink, so we're not going to keep that. It needs to have all 3 colors. This has just blue and green, so we're not going to keep this region. It needs to have all 3 colors. This has pink and blue and green, so we're going to keep this region right here that my pointer is going crazy in, okay? We're going to keep this region, okay? So let's erase all of our shading, okay? And then shade that region back in, okay? There we go. There's our solution. So what this means is that every point, if we take an ordered pair from this region, the x and y for that ordered pair are going to satisfy all 3 of these inequalities. If we plug the x and y in our ordered pair in for these, all of these inequalities will hold true. Okay, so that's what that means. Okay, let's do one more of these. Okay? So first, I need everything in slope-intercept form. Okay. So that gives me y is greater than or equal to 2 minus 2/3 x. Okay. Over here, minus x. Okay. We're going to divide by -1. Guys, remember, when we divide by negatives, when we're solving inequalities, we got to flip, right? Dividing by a negative here means I got to flip this inequality symbol. So we're going to have y is greater than or equal to -3 plus x. Okay. All right, and then this is just going to be y is less than or equal to 2. Yep. So I'll highlight this top inequality in pink, highlight the middle inequality in green, highlight the bottom inequality in blue. Okay. I think that's it, right? Check my work. Looks good. Looks good to me, okay? Looks good to me. Yep. All right. So let's start with the pink, okay? So we're going to graph this just as if it were the line y equals 2 minus 2/3 x. And we're going to use a solid line, right? Solid line because we have a greater than or equal to. Okay, so plot my y-intercepts, and then what is that? Negative 2/3 is my slope, so down 2 over 3. There we go, right there. There we go. And there you go. There we go. Okay. So this is the line where y equals 2 minus 2/3 x. We want to shade all the points where y is greater than 2 minus 2/3 x. So we're going to shade up, above. Oh, excuse me. There we go. All right, now this green line, this green inequality, okay? So we're going to graph this just as if it were the line y equals negative 3 plus x. All right, just as if it were y equals negative 3 plus x. And I'm going to use a solid line because I have y is greater than or equal to negative 3 plus x, okay? All right, so y-intercept. 3, and then positive 1 is my slope. Positive 1 is my slope. There we go. Right, so this is the line where y equals negative 3 plus x. We want to shade all my points where y is greater than negative 3 plus x, so above this line. Above the green line. All right. And again, now we'll do the last inequality. So we're going to graph my blue inequality just as if it were the line y equals positive 2. Okay. And we're going to use a solid line because I have y is less than or equal to 2. Okay. So let me do that here real quick. There we go. Boom. All right. Good. All right. So let's shade. Okay. So this blue line is the line where y equals 2. We want to shade all my y's that are less than or equal to 2. So we're going to shade below the blue line. Below the blue line. Okay. Wait, did I? Okay, yeah. So we're going to shade below the blue line. All right. So there we go. And then, I'm sorry, guys. I just realized I forgot to shade for my green line here, okay? So let's see. Let's look at my green inequality, my green stuff. So this green line is the line where y equals negative 3 plus x. We want to shade all my y's that are greater than or equal to negative 3 plus x. So we're going to shade above the green line. There we go. And this starts to become like kind of a cluster of colors, okay? Again, we want to keep the region where all 3 of my colors are shaded in, okay? So this has just blue. We don't want that. This has blue and green. We don't want that. This has just green. We don't want that. This has pink and green, we don't want that. This has just pink, we don't want that. This has pink and blue, we don't want that. I'm pretty sure the only region where there's all 3 colors is this little small little triangle right here, right? Here we go. Yeah, we're going to keep this region right here. Illuminati, Confirminati right here, all right? Illuminati, okay? Just that little triangle, okay? So let's shade in this little triangle right here, okay? So I'm going to erase what I have shaded in thus far, and then I'm going to zoom in here, make my highlighter a whole lot finer. There we go, and I'm just going to shade the yellow region here. All right, so this means that if we pick a point inside this yellow region, the ordered pair for that point will, if we plug it into these three inequalities, it'll satisfy each one, okay? If we plug and simplify, then we'll get inequalities which hold true, okay? So that's it for G. Let's move on to this word problem here, okay? All right, so in order to prepare for your summer bash, go to the supermarket, buy some burgers and chicken. Hamburgers cost $2 per pound. Chicken costs $3 per pound. You don't have any more than $30 to spend, and we want to purchase at least 3 pounds of hamburgers. Okay? Write a system of inequalities, graph them, give 3 possible combinations for buying hamburgers and chicken for your summer batch. Justify your answers. All right. It says many parts. This problem has many parts. Unlike God. God has no parts, guys. Just little side note, God is simple. He has no parts. But anyway, going back to this problem, okay? Let's let X equal pounds of burgers bought. Let's let Y equal pounds of chicken bought. All right. And then looking through my word problem, there's going to be my two inequalities are going to come from 2 restraints here, right? One is you expect to purchase, let me make my highlighter a little bigger. You expect to purchase at least 3 pounds of hamburgers, okay? All right, so what's that going to mean? It means the number of pounds of hamburgers I buy has to be at least 3. It has to be greater than or equal to 3. So X is greater than or equal to 3 is what I get from this, okay? All right. Let me highlight that in pink just so you guys can remember. Okay. And then what's my other constraint? My total money, I have no more than $30 to spend, okay? So the total amount of money I spend is going to be $2 times the number of pounds of burgers I bought, because burgers cost $2 per pound. So $2 times the number of pounds of burgers bought that's the total money I spend on burgers. All right, we're going to have to add to that the amount of money I spend on chicken, which is going to be what? 3Y, okay? So it costs $3 per pound of chicken, and I'm going to buy Y pounds of chicken, okay? Right, so that's going to be the total money I spend on chicken. The sum of these 2 terms is going to be the total money I spend. And that has to be what? I have no more than $30 to spend, so that has to be less than or equal to 30, okay? So this right here is my system of inequalities, okay? Oh, sorry. All right. There's my system of inequalities. So we did the first part of the problem, check. Okay, now let's graph the system on this grid, okay? So this pink line, this pink inequality I'm going to graph just as if it were the line X equals 3. I'm going to use a solid line because it's a greater than or equal to symbol. So X equals 3 is right here. All right. Let's shade, okay? So this is the line where X equals 3. I want to shade all the X's that are greater than or equal to 3. So X greater than means I'm going to the right because X increases as I move to the right on my graph. So I'm going to shade to the right. Oh, man. Let me make this a little bigger. It'll take me a little bit. Ugh, drawing is so hard. There we go. Okay. All right, and then my green inequality right here to graph that, I want to put it in slope-intercept form first. So minus 2x, and then divide by 3, So I have y is less than or equal to 10 minus 2/3 x. And I don't flip my inequality symbol when I divide by positive 3 because it's positive, so I don't have to do anything, okay? So let's graph this. I'm going to graph it just as if it were the line y equals 10 minus 2/3 x, okay? All right, so I'm going to use a solid line because I have y is less than or equal to 10 minus 2/3 x. So let me go up 10 on the y-axis. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, and then my slope is negative 2/3, so I'm going to go down to right 3. All right, I'm going to graph that. Oh, this is tough. There we go. Drawing's the hardest part for me. Okay, here we go. So this is the line where y equals 10 minus 2/3 x. We want to shade all of our y's that are less than or equal to 10 minus 2/3 x. So I'm going to shade below this line because that's y decreasing, okay? There we go, okay? So then we're done shading, okay? So we want to keep the region that satisfies both these inequalities. That's the region where both colors are shaded, okay? So right here we have pink and green right here. We're going to throw out the just pink region and the just green region and the white region. We just want to keep this one, okay? So let's erase my shading. Keep this region where we had both colors shaded. Okay. There we go. So we graph the system of inequalities on the grid. Okay, now we're going to move on to give 3 possible combinations for buying burgers and chicken for your summer bash. How do I do that? So what this graph means is that with my system of inequalities here, right, if we pick a point in here, any ordered pair in this region, okay, in this region, if I plug that into my system of inequalities, it's going to satisfy both of them, okay? So let's show that. So let's pick 3 points in here. Let's do 5, 2. Let's do, what is this? Is that 8? 8, 1. 8, 1. Let's do 12, 0. 12, 0. Okay, so we're going to show by plugging these into my inequalities that they satisfy my system. Okay, so what is my system of inequalities? It's going to be x is greater than or equal to 3, y is less than or equal to 10, or, yeah, I'll keep the original. 2x plus 3y is less than or equal to 30, okay? Okay, so I literally just, this black part I just copied from up here. I copied the pink, put it down here, copied the green right here, and put it down here, okay? So the point, let's start with 5, 2. So first of all, 5, so my x, 5, 2 means x equals 5 and y equals 2. Okay, so 5 is greater than or equal to 3, so that checks out. I'm buying at least 3 pounds of hamburgers. And then 2 times 5 plus 3 times 2, that equals 10 plus 6, which equals 16, which is less than or equal to 30. So I'm only going to spend $16. We're under budget, okay? So that works, okay? Now let's do 8, 1. That means x equals 8 and y equals 1, okay? So that means, first of all, my x, which is 8, is greater than or equal to 3. So I'm buying at least my 3 pounds of hamburgers, okay? Then I have 2 times 8 plus 3 times 1, which equals 16 plus 3, which equals 19. That's less than or equal to 30. Yep, so I'm spending $19, which is coming under my budget of $30, okay? And then let's check 12, 0. So that means x equals 12. Y equals 0, yeah, because screw chicken. Who likes chicken? No, I'm kidding. I love chicken. I love chicken. But sometimes you're just in the mood for red meat. So, yeah. So we're going to buy 12 pounds of hamburgers, right? First of all, our x12 is greater than or equal to 3. So we're buying enough hamburgers, right? We're really going heavy on the red meat, all right? And then for my second inequality, we have 2 times my x, which is 12, plus 3 times my y, which is 0. That equals 24, and that's less than or equal to 30, so we're coming in under budget, okay? So that satisfies all my conditions, okay? There we go. So we gave 3 possible combinations for buying hamburgers and chicken for our summer bash, and we justified our answers by showing with math that they satisfy my 2 inequalities, okay? So go ahead, guys, if you were confused by something in this section, rewind, replay, pause, email me, ask Mr. Miller for help, okay? So you guys will do the homework assignment with him in class. You guys take care.